The Bloomington and Normal Water Reclamation District's J. Michael Callahan Southeast Wastewater Treatment Plant was constructed from 2001 to 2005 and was opened for full service operation on June 1, 2005. It can process nearly 17 million gallons of wastewater per day. This facility treats municipal wastewater from the north, east, and southeast sections of the Bloomington Normal metropolitan area, as well as the village of Downs and portions of the nearby Crestwick subdivision. 14 miles of sewers across the area are utilized to transport water to the facility. The plant operations are monitored and controlled by a supervisory control and data acquisition, or SCADA system. The system can operate the entire plant automatically and alert employees in the event of a problem. The system is connected to other BNWRD facilities by broadband and wireless radio networks. Wastewater is delivered to the Headworks building by gravity through the Eastside Interceptor system. The facility uses 3 Archimedes screws to lift raw sewage up to ground level for preliminary treatment. The screws are installed in semicircular concrete channels and can pump sewage without clogging or damage. After pumping, screening and grit removal is performed with separate areas for the collection of the grit and screenings from the waste stream. 2 mechanical screenings units remove solids material, trash, and debris from the water. The solids removed from the waste stream are sent to automated solids processing station, which includes conveying, washing, and compaction units. Grit removal follows the screenings process and is carried out in 2 concrete basins called grit traps. Non-potable water is also extended to the lower grit hopper to flush and suspend settled grit solids. The settled grit from the traps is called slurry, a mixture of wastewater, inert solids, and organic materials. This slurry is passed through a cyclone separator, a grit classifier, and a grit washer. The washed inert solids are deposited into dumpsters by a shaftless screw conveyor. The screened and degritted wastewater flows to the primary lift station for primary treatment. The wastewater is piped from the preliminary treatment facility to the influent pump station, where 3 125 horsepower pumps move the water uphill to the primary distribution box and then onto the primary clarifiers. The influent pump station has a dry well, wet well configuration. The concrete wet well collects the sewage flow from the preliminary treatment building, while the pumps, valves, gauges, and discharge pipings are located in a concrete dry well adjacent to the wet well. The pumps modulate automatically based on water level, which is measured by submersible level transducers in the wet well. Each pump has an accompanying 24-inch isolation, plug, and check valves. Pressure gauges are located on both ends of each pump, and a water seal unit system allows the continuous supply of water to the pump shaft seals. The flow can be monitored by an ultrasonic flow meter located in a manhole outside the building. 2 primary clarifiers are concrete tanks with a peripheral trough cantilevered inward from the perimeter wall. Outlet weirs, or small dams, extend from the edge of the trough along with the baffles located below the surface, which retain floating solids. Incoming flow from the primary distribution box passes under the basin and travels to the center column pipe of the clarifier. The flow is directed upward in the pipe and is distributed to the settling zone in the center. Flow is directed outward and exits a clarifier under the scum baffles, over the perimeter weir, and into the outward flowing trough, where it flows by gravity to secondary treatment. The blanket of sludge, which settles and collects at the bottom of the clarifier, is continuously raked by rotating arms and directed to the outward flowing sludge hopper. A surface skimmer mechanism collects and deposits sludge in the sludge draw-off box. Sludge from the north clarifier box is discharged to the south clarifier box, which also acts as a wet well for the sludge transfer pump station. The primary sludge transfer pump station collects sludge and scum from both clarifiers and discharges to the primary digester. A non-potable water supply with an actuated plug valve is provided for the wet well to aid in flushing and pumping. The aeration system is designed to provide oxygen to the liquid in the aeration basins to suspend the solids and stimulate the growth of the microbes utilized in the secondary treatment system. Air is supplied to the basins by three 300 horsepower high-speed blowers located in the pump blower building. In each aeration basin, air is fed to three independent aeration zones or service drops. Airflow is measured and locally indicated at each zone, and the airflow can be adjusted via a modulating butterfly valve. Oxygen levels are measured in 2 aeration basins or 6 aeration zones to allow the control of airflow to each aeration zone and to maintain the proper oxygen levels. 2 concrete circular clarifiers settle out the biomass from the aeration basin effluent under quiescent or inactive conditions. Flow to the clarifiers is routed through a distribution box, and each clarifier can be operated independently. Effluent from both clarifiers is discharged to a common secondary manhole for transfer to tertiary treatment. Sludge is transported through the rotating collector header to the center manifold and a pipe with multiple branches and openings. The center manifold at the clarifier base, along with a telescoping valve, continually transfers sludge to the aeration or anoxic basins to maintain a set concentration of mixed liquor suspended solids, or MLSS. The scum collection system consists of a surface skimmer with a stationary anti-rotational scum baffle, a scum blade, and a scum trough. The scum trough discharges to the secondary scum transfer pump station between the clarifiers. The pump station pumps the scum to the headworks building for further treatment. At the southeast plant, tertiary treatment includes low-head traveling bridge filtration, followed by ultraviolet disinfection. The filtration system at the plant utilizes a 3-part sand and anthracite media bed. The ultraviolet disinfection system exposes the incoming water with ultraviolet light, which changes the DNA structure of the bacteria in the water and prevents them from reproducing. 2 gravity belt thickeners are housed in the residuals building. The GBTs are used to thicken the waste-activated sludge generated by the secondary clarifiers. Each GBT unit also contains a trip cord connected to an emergency stop switch to immediately stop the belt drive and shut down the entire system in the event of a problem. The belt filter press is used to remove water from the sludge drawn from the secondary digester. The BFP has 3 zones: the gravity dewatering zone, the adjustable wedge zone, and the pressure zone. Anaerobically digested sludge, after flocculation with polymer, is introduced in the BFP. Initial dewatering occurs by gravity when sludge travels horizontally through a filter belt. The sludge is then squeezed between 2 horizontal pressure belts, first through a wedge zone and then over and under a series of drums, forcing water out of the sludge through pressure and shear action. Finally, sludge cake is discharged and the BFP belt is washed with high pressure and low volume water. Filtrate and wastewater is collected in drain pans and directed to a basin under the unit. The BFP system also contains a conveyor system that transports cake sludge from the BFP to trucks in the adjacent garage bays. The biosolids are then transported to the BNWRD's West Plant for further drying and preparation for land application to crop fields as fertilizer. Digesters at the plant use anaerobic bacteria to destroy organic solids in the sludge using chemically obtained oxygen as well as nutrients in the sludge for energy. As the microorganisms digest the sludge, they produce carbon dioxide, methane, and hydrogen sulfide. The process is performed at 95 degrees Fahrenheit for a minimum of 15 days to ensure sufficient volatile solids and pathogen reduction. Mixing is also done to ensure that active organisms are kept in contact with the sludge for an even heat distribution. At the plant, the digestion process is mainly performed in the heated primary digester, followed by an unheated unit of similar size called the secondary digester. The raw primary sludge from the primary clarifiers and the polymer-thickened waste-activated sludge are pumped directly to the primary digester. Methane gas is collected from the digesting process and is used as fuel in a digester boiler and heat exchanger to maintain the required 95 degrees Fahrenheit sludge temperature. Any excess gas that is produced is flared off through the waste gas burner. The wetlands are part of the Kenneth L. Schroeder Wildlife Sanctuary, which consists of 265 acres of native prairie grass, upland savanna, several forest areas, and the wetlands. The wetlands themselves consist of 3 cells, the first 2 of which were constructed in 2005. One is 1.5 acres, the other is 6 acres. In 2013, an additional 11-acre cell was created, bringing the total acreage to 18.5 acres. Wetlands were created to measure further nitrogen and phosphorus removal of the wastewater after it has been discharged from the plant. Hundreds of birds use the wetlands ponds and surrounding forests as habitat throughout the year, but especially in the winter. The large number of birds has made the wetlands an attractive spot for bird watchers and other members of the general public. The trails that run through the area are open from dawn to dusk. The E. Burton Mercier Conservation Area is a 238-acre tree farm purchased by BNWRD in 1990. It's located on the north and south sides of Shirley Road, 1.5 miles west of US 51. Initially, 34,000 trees were planted, including red oak, walnut, white and green ash, and maple trees. In 1995, 5,000 pine, persimmon, and pecan trees were planted. At the tree farm, biosolids are applied to some trees, but not to others. This is done to measure the benefit the biosolids have on tree growth. The farm also contains corn, soybean, and wheat fields, which are rotated annually. These fields have biosolids applied to them. The farm is subject to strict state and federal EPA standards, which are followed by BNWRD. In 1994, the farm received the EPA Award for Innovative Biosolids Disposal. It was among the top 5 awarded winners that year out of over 16,000 publicly owned treatment works in the country. Recently, many of the ash trees on the farm have died due to the spread of the emerald ash borer. However, this loss is not a significant problem. The ash trees were planted as training trees for the other hardwoods so they would grow rapidly in the initial years, and their removal was already planned.